So guys, we are starting with definite integration. Exercise 16A. Exercise 16A. Okay. Question number one. Sub question one. Integration of cot x dx. We are having 5 by 4 down, and at the top we are having 5 by 2. Okay. So integration of cot x. The formula is log mod sin x. Integration of cot x. The formula is log mod sin x. Okay. 5 by 4 is the lower limit of the problem. You didn't see this things in okay. And 5 by 2 is the upper limit of the problem. Okay, so whenever we have upper limit and lower limit, this is definite integration. Okay, so let's put a box bracket over here. In definite integration, we have to put a box bracket. So down, I'm going to write 5 by 4, and up, I'm going to write 5 by 5, 5 by 4, and 5 by 2. Okay, there is no plus c in definite integration. There is no plus c. Remember this. Okay, then after this step, I'm going to write box minus box, box minus box in place of the first box. Okay, in the first box, x will be first replaced with the upper limit, and in the second box, x will be replaced with the lower with a minus sign in. Hence, I'm writing box minus. Hence, I'm writing box minus. Okay, so this can be written as log sine pi by 2. Log sine pi by 2 minus log sine pi by 4. Okay, in place of x, first I'm putting the upper limit, and in place of x, next I'm putting the lower limit. Fine. So this is log sine 90 degrees minus log sine 45 degrees. Okay, 5 by 2 is 90 and 5 by 2 is 45. Now sine 90 is 1, and sine 45 is 1 by root 2. Sine 45 is 1 by root 2. Log 1 value, always remember, log of 1 is 0. Okay, so this is minus log 1 by root 2. Minus log 1 by root 2. Fine. Now textbook people have solved this, right? There is no need to further simplify this. Till this point it is fine. Second problem, same exercise. Sub question 2. Integration of dx upon sine 2x. Integration of dx upon sine 2x. Lower limit is 5 by 6. Upper limit is 5 by 3. Okay. So this can be written as cosec 2x dx. See guys, there is sign in the denominator. So when this sign goes up in the numerator, its reciprocal becomes cosec. Okay. Now the integration of cosec x. This formula you already know. Integration of cosec x. It is log mod cosec x minus cot x. Okay. but in chain rule will get applied, and we also have to write d by dx of 2x. The d by dx of 2x part will come down because we are integrating. I'm comparing this with cosec x formula. Okay, so who is x? X is 2x, and 2x is linear algebraic term. 2x is linear algebraic term, so chain rule is quite applicable over here. Fine. So instead of pi by 3, I'll just write 60 degrees, and instead of pi by 6, I'll just write 50 degrees. I hope you know how to calculate this radians to degrees. Take pi as 180 and then you can just get it in degrees. Okay. So next step, I'll just write box minus box. Box minus box. So in the first box, I'll write everything same except wherever there is x, I'm going to put 60 degrees in the first box. So log modulus cosec 2 into 60 degrees minus cot 2 into 60 degrees, okay, upon 2 minus log modulus cosec 2 into 30 degrees minus cot 2 into 30 degrees upon 2. So what I've done after this particular step, entire box bracket is there, so I've written box minus box. In the first box, wherever there is x, I'm putting the upper limit, and in the second box, wherever there is x, I'm putting the lower limit. Okay, this way. So this will become cosec 120, cot 120, cosec 60, cot 60. Okay, so cosec 120 is the reciprocal of sine 120. Fine, you can very well use a calculator for that. Sine 120 in degrees. Okay, so what is the value of cosec 120? Have you figured out? So I'll teach you. Cosec 120 is equal to 1 upon sine 120. It is 1 upon sine 90 plus 50. Okay, right? Now 90 is at the top over here, 90 degrees. Plus, whenever it is plus, it is always anti-clockwise direction. Plus is always anti-clockwise direction. If you don't know this method, you can take notes. Plus is always anti-clockwise direction, 30. So the angle will lie over here. Okay. Now in the second quadrant, sine is always positive. Sine is always positive. In the second quadrant, sine and cosec are always positive. So sine is always positive. And 90-degree lies on the y-axis. So on y-axis always there are changes. So what are the changes? Sine changes to cos. So this sine will change to cos. So this will be cos 30. So 1 upon root 3 by 2, which is 2 by root 3. So we got the value of cosec 120. So cosec 120 is 2 by root 3. Okay. So I'll just replace this by 2 by root. Fine. Now we have to calculate cot 120. I'll teach you how to calculate cot 120. So cot 120 is equal to 1 upon tan 120. 1 upon tan 90 plus 30. So 90 is on the top plus anti-clockwise direction, right? So in this quadrant, your tan is negative. Your tan is negative because in the second quadrant only sine and cosec are positive. Tan is negative, okay? And 90 is on the y-axis. 90 is on the y-axis. So tan changes to cot 30. Okay. So what is the value of cot 30? Anyone? So we can write this as minus 1 upon cot 30. So minus 1 upon, yes. Can you tell me the value of cot 30?
So root 3.
Cot 30 is root 3. Okay. So this is minus 1 by root 3. So I'll replace cot 120 by minus 1 by root 3. There is already a minus sign over here. It would mean minus 1 by root 3. Okay. Then I'll complete the modulus. Now next value is cosec 60. Cosec 60. Okay. Cosec 60 is the standard angle. It is 1 upon sine 60. So sine 60 is root 3 by 2. Okay. So cosec 60 will be 2 by root 3 minus cot 60. Cot 60 is the reciprocal of tan 60, right? So tan 60 is nothing but root 3. So cot 60 will be 1 upon root 3. Cot 60 will be 1 upon root 3. Okay. Just put a modulus over here. Now, when I calculate the upper part over here, the calculation of this particular part is 3 by root 3. So I'll write log 3 by root 3 by 2 minus log the second bracket. Second bracket, the calculation will be 1 by root 3. 1 by root 3. Okay. So this is log 3 by root 3 minus log 1 by root 3. Okay. So this becomes log a minus log b. Log a minus log b. Guys, what is log a minus log b? If at all you recollect.
Log A by B.
Correct. Very good. So that is log a divided by b. Okay. I'm going to the next slide. Log a divided by b. Okay. Even if you don't want to put a modulus at this particular step, that's okay. So 3 by root 3 into root 3 by 1. So root 3 will get cancelled. You will get the answer as 3. So this will be log 3 upon 2. That is the final answer. Okay. Question number 1. Sub question 3, a relatively simple problem in terms of formula application. 2 sec square x plus x cube plus 2 dx. Okay, lower limit is 0, upper limit is pi by 4. Okay, so this is individual integration. 2 is a constant. Integration of sec square x is tan x. Okay, this is x raised to n. X cube is x raised to n. So x raised to 3 plus 1 upon 3 plus 1, that is x raised to 4 by 4, plus integration of 2. 2 comes outside, that is integration of 1. And integration of 1 is x. So the integration of 2 will be 2x. Okay, these are the basics of integration. Okay, no plus c over here. And 45, pi by 4 is 45, so I've written 45 degrees. But then see, there are some values which are not angles. Only tan x, x is the angle. So let's keep this as pi by 4 only. Okay, because each and everything is not a trigonometric function over here. There are algebraic functions also. Okay, but then at the back of our mind, we should know that pi by 4 is 45 degrees when it comes to angle. So now after this particular step, I'm going to do box minus box. In the first box, wherever there is x, I'm going to place the upper limit. And in the second box, wherever there is x, I'm going to put the lower limit, that is 0, with a minus sign in between. Okay, so let's start. So 2 tan pi by 4 plus pi by 4 raised to 4 upon 4, 2 tan pi by 4 plus pi by 4 raised to 4 upon 4 plus 2 into pi by 4. Okay, next bracket, 2 tan 0 plus 0 raised to 4 upon 4 plus 2 into 0. So wherever there is x, I am putting the lower limit. Okay, guys, can someone tell me what is the value of the entire second bracket? If you
0.
can think, the entire second bracket will be 0 because tan 0 is also 0. Okay, so we are only concerned with the first bracket. So this will be 2. Okay, tan pi by 4 indicates tan 45 degrees. So this will be 1. So next step, I'll write it as 2 into 1 plus pi raised to 4 upon 4 raised to 5. How this became 4 raised to 5? So it is pi raised to 4 by 4 divided by 4. So pi raised to 4 by 4 raised to 4 into 1 by 4. So if we multiply 4 raised to 4 into 4, it will give us 4 raised to 5 plus pi. Okay, so this is our answer. 4 raised to 5, you can obviously you can expand using a calculator. Okay, so this is,
1024.
yeah, this is your answer. And the last term will be pi by 2. Sorry, because there is a 2 left over here. Okay, and this will be 2. Now no need of a box bracket, you can just simplify this further. Question number 4, integration 0 to pi sine square x by 2 minus cos square x by 2 dx. Now going to your exams without half angle formula, it will be a blunder, right? So see this, cos 2x formula we know. Cos 2x formula is cos square x minus sine square x. half angle or let's say double angle formula. Okay. So what will be cos x?
Cos square x
Cos
by
x will
2
be
minus sin square x by 2.
correct. Cos square x by 2 minus sin square x by 2. Now if we reverse this, okay, can we write in this particular manner? If we reverse the negative sign. See in mathematics, a minus b can be written as minus of b minus. Okay. Now why? What is the need to reverse? Because we are having the term in which sign is there first. So I have reversed. Okay. So this becomes cos x. Okay. So guys, tell me what is the value of sin square x by 2 minus cos square x by 2? What is the value of this? From this, can you tell me?
Minus cos x.
Correct. It is minus cos x. Perfect. It is minus cos x. Okay. So those who are copying, please copy this. I'm going to replace the integration with minus cos x. This step I'm going to replace with minus cos x. Yeah. So next step, integration of minus cos x dx. Okay. On the top, we are having pi. Down, we are having 0. So minus sign outside. And what is the integration of cos x?
Sin x.
Integration of cos x is sin x. Let's put a bracket over here. 0 to pi. Okay. After this, box bracket minus box bracket. Minus sin pi minus sin 0. So pi is 180 degrees. So sin 180. Sin 180 is 0. Okay. Now minus into minus is plus. And sin 0 is also 0. So the answer is 0. So the answer is 0. Okay. Yeah. So question number 2, sub question 1, integration dx upon 2x minus 3, 0 to 1. So this is 1 upon 2x minus 3 dx. You can do two things over here. You can use 1 upon x formula or f dash x upon f of x property. Okay, I'll go ahead with 1 upon x formula. Integration of 1 upon x, where x is 2x minus 3, where x is 2x minus 3. 2x minus 3 is linear algebraic term. So obviously we can apply chain rule over here. Okay. So this is log modulus 2x minus 3. Okay. Box bracket 1 and 0. See, I said you this is just a revision of basics of integration. Okay. So further, this will be box minus box, box minus box. Wherever there is x.
So down upon 2 won't come.
Yeah. I just forgot the chain rule. Thank you for that. Okay. So down it will be upon d by dx of 2x. Correct. Because we are applying the chain rule. D by dx of 2x minus 3. Okay. So this will be log modulus 2x minus 3 upon 2. Okay. And then 1 and 0. Perfect. Now you can write box minus box. Okay. And in the first box, in place of x, what are you going to substitute?
1.
Correct. And in the second box, in place
0.
of x, you will be substituting 0. Perfect. Good. Okay. So if you have copied this, I'll go to the next slide. So this will be box minus box upon 2 log modulus 2 into 1 minus 3 log modulus 2 into 0 minus 3. Okay. So log modulus minus 1 log modulus minus 3 upon 2. Okay. What is modulus of minus 1? It is 1. And modulus of minus 3, that is 3. Log 1 is 0. This is minus log 3 upon 2. Okay. Textbook people, I think they have simplified it further. No, they have the same answer. Okay. We can simplify these things further, but then we can stop it over here. Even the textbook has stopped over here. Fine. Okay. So the next problem is same exercise, question number 2, sub question 2. But then I will discuss this problem. I will probably not solve it further. This is the same thing, 1 upon x formula. Okay, 1 upon x formula. You can do this on your own. Fine. So question number 2, sub question 2, I'll just give it for self study. Let us go to question number 3, sub question 1. Question number 3, sub question 1. Now, if you remember indefinite integral 1, then this problem will be simple for you. Otherwise, it will be difficult. Okay. So I'll just teach you how to solve this. Cos square 3x dx. Now, whenever there is integration of sine square and integration of cos square, we use always half angle formula for cos 2x. Okay. So 1 plus cos 2x, 1 plus cos 2x is equal to 2 cos square x. Okay. This is the half angle for 1 plus cos 2x. But then we require cos square 3x. We require cos square 3x. So what should be the angle over here to get cos square 3x?
Cos 6x.
It should be 6x because the half of 6x is 3x. Okay. I hope you guys understood this. Therefore, cos square 3x is equal to 1 plus cos 6x upon 2. We got the value of cos square 3x. We got the value of cos square 3x. Okay. Fine. So I'm going to replace this with 1 plus cos 6x upon 2. Should I go to the next slide? Okay. So I is equal to integration 1 plus cos 6x upon 2 dx. Okay. 0 and 45. Let's not write 45 because there might be some algebraic terms in the integration answer. Okay. Let's take half outside. Guys, what is the integration of 1?
X.
Integration of 1 is x. Or you can take half inside also. You can just write it by 2. Okay. So integration of x is, integration of 1 is x. Anyone, what is the integration of cos 6x?
Sin 6x.
Upon dividing
Correct.
Upon.
X.
Correct. Upon dy dx of 6x, that is 6. So this is the integration of the entire term. 0 and pi by 4. So I think we have integrated. Okay. Now, after this particular step, what I'm going to do is I'm going to do box minus box. Box bracket minus box bracket. In the first box, wherever there is x, what will I substitute?
45.
I will substitute 45 is right when
Pi
it is
by
a
4, no?
trigonometric function. Okay. Yeah.
Yeah.
So in the first place, you can put 45. You can put pi by 4, but then in the second place, you can just simply write 45. That's fine. But then in the first place, you cannot put 45 degrees. Okay. So box minus box. In the first box, x will be replaced with pi by 4 plus sine 6 pi by 4 upon 6 by 2 upon 2. And in the second box, x is 0. Okay, x is 0. So sine 6 into 0 upon 6 by 2. Okay, can someone tell me the value of the second box entirely?
0.
Very good, 0. Because this is 0, 6 into 0 is 0, and sine 0 is also 0. Okay, so 0 upon 6 is 0, 0 plus 0 is 0, 0 divided by this 2 is 0. Okay, so the second box entirely becomes 0. First box will simplify. This will be 3 by 2. Okay, so pi by 4 plus sine 3 pi by 2. 3 pi by 2, if I'm not wrong,
27.
it is sine 270, because 3 into 180 by 2, na? So sine 270. Now sine 270 value, you can pull it out from your respective calculators. Sine 270, it is -1. Okay, so I'll just write this on the next step, and remember that the second box is altogether 0. So pi by 4 plus -1 by 6 upon 2. Okay, we can simplify this. Okay, uh, so let's take the LCM into 2 into 2 into 3 into 3. So 3 pi by 12 minus 2 by 12 divided by 2. So that is 3 pi by 2 by 12. 3 pi minus 2 by 12 into 1 upon 2. 3 pi minus 2 upon 24. 3 pi minus 2 upon 24. Be careful about your calculations. Okay, don't make any silly mistakes anywhere. Okay, so that's it. Textbook has further split this into two parts: 3 pi by 24 minus 2 by 24. That's okay, that's your choice. You can do that, or you can leave it as it is. Question number 3, sub question 2. Okay, pay attention. Integration of tan square x dx. Integration of tan square x dx 0, and this is pi by 4. Guys, can you recollect what is the formula for tan square? Do we
Tan
have a
x
formula for?
sec x tan x.
No. There is no
No,
integration
log sec
formula
x,
for tan
log
square.
sec x plus tan x.
No, there is no integration formula for tan
So do
square x.
sec
Sorry,
square x minus 1, right?
correct. So whenever there is tan square and cot square, always first apply fundamental identity. So tan square x is replaced with sec square x minus 1. So whenever there is tan square x, x or cot square x, always apply fundamental. Now we can individually integrate this, because integration of tan square x is, integration of sec square x is tan x, and integration of 1 is x. Integration of 1 is x. So 0, and this is pi by 4. 0, and this is pi by 4. Okay. After this step, what are we supposed to do? Any suggestions?
Box brackets 2.
Correct. Box minus box. Box minus box. So I'll do box minus box after this. Okay. So tan pi by 4 minus pi by 4. Tan pi by 4 minus pi by 4. And tan 0 minus 0. The value of the second bracket is 0. Tan pi by 4. So tan 45 is 1 minus pi by 4. This is your final answer. This is your final answer. Okay. Yeah. So I'll proceed with the next sub question. I'll proceed with the next sub question. Question number 3, sub question 3. Integration of tan x plus cot x to the whole square dx. Up we are having pi by 4 and lower limit we are having pi by 3. Okay. So will a plus b the whole square will apply this. So it will be integration of tan square x plus cot square x plus 2 tan x cot x. I have applied the formula of a plus b the whole square, right? Pi by 3, pi by 4. Guys, what is tan x into cot x? Tan x into cot x is 1 because tan and cot are reciprocals of each other. Otherwise, convert into sin and cos and cancel it out. Now, this tan square x can be written as sec square x minus 1. Cot square x, I can write it as cosec square x minus 1. Okay. So I'm going to apply fundamental identity once again. And towards the end, we are having this too. So next step, sec square x minus 1 plus cosec square x minus 1 plus 2 dx. Okay. Pi by 3 and pi by 4. Fine. So if you take a look at the step which I have written, okay, so minus 1 and plus 2 will get cancelled. Minus 1 plus 2 will get cancelled. Integration of sec square x is tan x plus integration of cosec square x is minus cot x. Okay. Pi by 3, pi by 4, tan x minus cot x, pi by 4, pi by 3. Please copy. And after this particular step, I'm going to do box minus box. I will do box minus box. Okay. So this is equal to box minus box. So in the first box, wherever there is x, I am going to put pi by 4. So tan pi by 4 minus cot pi by 4. In the second box, I'll write tan pi by 3 minus cot pi by 3. So tan 45, that is 1. Cot 45 is also 1. Minus tan 60. Tan 60 is
Root 3.
root 3. And cot 60. 1 by root 3. Okay. So this is 0. Take this minus sign inside, the answer will be minus root 3 plus 1 by root 3. Minus root 3 plus 1 by root 3. Because this minus into this minus will be this plus. Okay. We can solve this further by taking the LCM.
Minus 2 by root 3.
Root 3 will be multiplied by root 3, so that is minus 3 plus 1, so minus 2 by root. So the final answer is minus 2 by root. Okay. If you take the LCM. Fine. So question number 4. Integration 0 to pi dx upon 1 plus sin x. Now we have a rule in integration that, not a rule kind of thing, but then this is one category of problem. Whenever there is 1 plus sign in the denominator, always rationalize it. Take conjugate. So 1 upon, whenever it is 1 plus sign or 1 minus sign in the denominator, always take conjugate. Okay. So this is the first step. Okay. Then down it will be a plus b into a minus b. A plus b into a minus b, a square minus b square. So 0 to pi 1 minus sin x. Down it will be a square minus b square. So 1 minus sin x upon 1 minus sin square x dx. 0 to pi. Please copy this. Now guys, what is 1 minus sin square x?
Cos
Anyone?
square x.
1 minus sin square x is cos square x. Zero to pi dx. Can someone suggest what can be done right now for this? How should we solve this
Split
side?
the numerator.
Very good. We can split the numerator. 1 upon cos square x minus sin x upon cos square x. Okay. So this equals 1 upon cos square x minus sin x upon cos square x. 0 to pi. 0 to pi. Okay. So this is sec square x minus, rearrange this, okay. So this will be sec x and this will be tan x, but then I'll write it as, while writing I'll write it as sec x tan x. While writing I'll write it as sec x tan x. Next step, integration of sec square x minus sec x tan x dx. 0 to pi. Integration of sec square x is tan x and integration of sec x tan x is sec x. These are ready-made formulae. Okay. Right. After this, we are going to do box minus box. Okay. So box minus box. In the first box, wherever there is x, I will be substituting the upper limit, and in the second box, wherever there is x, I'll substitute the lower limit. So it will be tan pi minus sec pi, tan pi minus sec pi, tan 0 minus sec 0. Pi is 180 degrees. So tan 180 is 0 sec pi. Now cos 180 is minus 1. So sec 180 is reciprocal of minus 1. So that is 1 upon minus 1. Tan 0 is 0. Okay. Cos 0 is 1. So sec 0 is the reciprocal of cos 0. That is 1 upon 1. Fine. So solve this and tell me what is the answer. What is the answer that you people are getting? Hello. 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 Are you guys there?
Yes, sir.
So what is the answer for this?
2.
Answer is 2. Correct. Answer is 2 because this minus and this minus will be plus. This minus and this minus will be plus. So 1 plus 1 will give me 2. Okay. Starting with question number 3, sub question 5. Okay, now before I start this problem, I have given you that logic. Sin A cos B, cos A sin B. Sin A sin B, cos A cos B. Okay, as in the multiplication between both the terms. If this type of problems occur in integration, we will have to use defactorization formula. Okay, defactorization. Fine. So integration of pi by 4 0 sin 3x sin 2x dx. So this is sin. So I'll write down the formula first. 2 sin A sin B is equal to cos A minus B minus cos A plus B. This is the defactorization for 2 sin A sin B. Okay. So 2 sin 3x sin 2x is equal to cos 3x minus 2x, that is x, minus cos 3x plus 2x, that is 5x. So what will be sin 3x into sin 2x? It will be cos x minus cos 5x. Just a second. Yeah, so it will be cos x minus cos 5x upon 2. Okay, we have to eliminate this 2, right? Because the problem does not have any 2. Okay, so in the main question, I'll replace sin 3x sin 2x with cos x minus cos 5x by 2. So this can be written as integration of cos x minus cos pi x by 2, 0 down, and at the top we are having pi by 4. Okay. Now here cos x integration will be sin x, and cos phi x integration will be, can you guys tell me?
Sin 5x by 5.
Sin pi x by 5. Okay. After this step, what are we supposed to do, guys? Can you just let me know?
Split the numerator.
No need to split the numerator. We can just do box minus box. Okay. So after this step, I'm going to do box minus box. In the first box, wherever there is x, I'm going to put pi by 4. So sin pi by 4 minus sin 5 pi by 4 by 5 upon 2. In the second box, sin 0 minus sin 5 into 0 upon 5 by 2. Okay. Second box, x, in place of x, I'm just replacing 0. Guys, can you tell me what is the value of the second box altogether?
0.
0. Correct. Because this is sin 0, which is 0. This also is sin 0, which is 0. So which will convert the entire box bracket into 0. Okay, the second box bracket. First bracket, sin 45 degrees minus sin 5 pi by 4. So that is 5 into 180 by 4. That is 225 upon 5 upon 2. Sin 45 is 1 by root 2. Sin 225 is, we need to calculate it precisely. That thing I will teach you right now. So sin 225 value calculation, please try and understand. Okay, because calculator will give you a decimal value. We'll try to get it in fraction somehow. Okay, so if your calculator is giving you a fractional value, that's fine. So is it giving you a fractional value? Sin 225? Yes or no? So if you don't know how to do that, we have a method. Sin 225, okay, is sin 180 plus 45. 180 is on the x-axis, plus indicates anti-clockwise direction. So in this quadrant, your sign is negative, okay, and we are on the x-axis. 180 is on the x-axis, so sign remains sign. There are no changes in the trigonometric function. So sign remains sign, sin 45. So this is minus 1 by root 2. Okay, minus 1 by root 2. Fine. So I'll solve this further. This minus and this minus will be plus 1 by root 2 plus, okay, 1 by pi root 2 upon 2. 1 by root 2 plus 1 by pi root 2 upon 2. So take 1 by 2 common in the numerator. 1 by root 2 common. Okay. So I'm taking 1 by root 2 common. 1 plus 1 upon 5 within the bracket. divided by 2. So this is 1 by 2 root 2. These two terms will be together. And the value of this entire term, 1 plus 1 upon 5, will be 6 upon 5. Okay. 2 ones are 2 threes are. So 3 upon 5 root 2. That is your answer. 3 upon 5 root 2, that is your answer. Okay. That was question number 3, sub question 5. So I'll go to question number 3, sub question 5. Integration of root of 1 minus sine 2x dx 0 pi by 4. Okay. Now 1 minus sine 2x, we are having a ready-made half angle formula. Cos x minus sine x the whole square. Okay. Now the root and square will get cancelled. So we'll be left with cos x minus sine x. We'll be left with cos x minus sine x. Okay. And then individual integration. Cos x integration is sin x, and sin x integration is
Minus cos x.
minus cos x. Okay. So let's put these values on the next slide. Cos x is sin x and sin x is minus cos x. Write down the upper limit and lower limit. The upper limit is 0. Lower limit is 0. Upper limit is pi by 4. So this is sin x plus cos x. 0 to pi by 4. Pi by 4 is 45. Okay. So this is box minus box. Sin pi by 4 plus cos pi by 4. Sin 0 plus cos 0. Between the two boxes there will be minus sign. Okay. Now this you can solve. Sin 45. Sin 45 will be 1 by root 2. Cos 45. Cos 45 will be 1 by root 2. Sin 0. Sin 0 will be 0. Cos 0. Cos 0 will be 1. Okay. So this will be 2 by root 2 minus 1. Okay. You can stop over here. No need to simplify this further. Fine. Okay. Question number 5, sub question 1. We are moving to question number 5, sub question 1. Integration 0 to 2 x raised to 4 plus 1 upon x square plus 1 dx. Upon x square plus 1 dx. Guys, the degree of the numerator is 4. Degree of the denominator is 2. Degree of the numerator is 4. Degree of the denominator is 2. When the degree of the numerator is greater than degree of the denominator, we have to divide the numerator by denominator. So we have to apply long division method. I hope you recollect this. X square into x square will give you x square. Okay. Then x square into plus 1 will give you plus x square. So we'll leave a line over here. Minus, minus. Okay. I should write x raised to 4 over here. Sorry. And after the cancellation, we are left with minus x square plus 1. Minus x square plus 1. X square into what will give you minus x square, guys? X square
Yeah.
multiplied by which term will give you minus x square?
Minus,
Waiting for your answer. Sorry?
minus 1.
Correct. It's minus 1. Perfect. So it is minus x square. Minus 1 into plus 1 is minus 1. Okay. Minus sign. This is plus. This is plus. Cancellation. This 1 plus 1 will give you 2. Okay. So that completes the long division. Let this be equation number 1. Guys, any doubts in the long division? You want me to explain it again? Okay, fine. So dividend upon divisor is equal to quotient plus remainder upon divisor. So dividend is x raised to 4 upon x square plus 1. X square plus 1 is the divisor. Quotient. We got the quotient as x square minus 1. So x square minus 1. The remainder. Remainder is 2. Remainder is 2. 2 upon x square plus 1. Fine. So from 1, integration will be x square minus 1, 2 upon x square plus 1. Fine. Now this 2 upon x square plus 1, I'm just writing it as 2 upon 1 plus x square. I'm
2
making
tan
this 1
inverse
plus
x.
x square. Yes, very good. Rightly identified why I'm doing that. Perfect. So 2 upon x square plus 1 ko I have just reversed it as 2 upon 1 plus x square. Now individual integration. Individual integration.
X cube upon 3 minus x plus 2 tan inverse x.
Perfect. This is x cube upon 3. Okay. Integration of 1 is x. 2 is a constant, will go outside. So it will be 1 upon 1 plus x square, and 1 upon 1 plus x square integration is tan inverse x. X cube upon 3 minus x plus 2 tan inverse x. Down, lower limit is 0 and upper limit is 2. Guys, do you have the same lower limit and upper limit? Or have I written something wrong?
No, it's right.
Okay, okay, fine. Thank you. So box minus box. Okay. So 2 cube upon 3 minus 2 plus 2 tan inverse 2. 0 cube upon 3 minus 0 plus 2 tan inverse 0. The second box is 0 because we are having 0 cube as 0. There is 0 over here. Tan inverse 0 is 0. Fine. So this will be 8 upon 3 minus 2 plus 2 tan inverse 2 plus 2 tan inverse 2. Okay. 8 upon 3 minus 2 will be 8 minus 6 upon 3. That will be 2 by 3. Plus 2 tan inverse 2. 2 tan inverse 2. Okay, so that's your final answer. Just verify whether you're getting the same or not. Okay. Yeah. Next problem. Next problem will be question number 5, sub question 2. Okay. Question number 5, sub question 2. Guys, can you tell me directly what is the answer for this?
Tan inverse x.
Correct. So this will be tan inverse x. What is tan inverse 1, guys? What is the value of tan inverse 1? Inverse figure.
45,
Perfect. And what is tan inverse root 3?
60.
60.
Correct. So I think this answers your question. But then final answer don't keep in degrees. Final answer keep in radians. Okay. So some paper correctors might not give you marks. Final answer if it is in degrees, don't keep it in degrees. Keep it in radians. For ITF it was okay. In this chapter, get it in radians. Okay. So this problem is for self-study. Let's go to question number 5, sub question 3. Okay, integration. Upper limit is 5, lower limit is 3. X square upon x square minus 4 dx. Now we will discuss this at length. The degree of the numerator and the degree of the denominator is same.
So divide
Okay.
by x square now.
No. If the degree of the numerator and degree of the denominator is same, we make
Oh,
numerator
plus
same
4
as
minus 4. Plus 4.
denominator. So tell me what should I write in the
Plus 4 minus
as the
4.
first term? I'll write it as x square minus 4. Okay. Will make numerator same as denominator. Now to nullify this minus 4, what should I write ahead?
Plus 4.
Plus 4. Correct. After this, we are going to split x square minus 4 upon x square minus 4 plus 4 upon x square minus 4 dx 2 and 5. There will be the cancellation of the first term. It will give me 1.
So 3 and 5 now.
Oh, sorry, 3 and 5. Correct. Right. So now we'll have to individually integrate both the cases. Okay. So I'll separate this integration of 1 dx, 5 and 3, 4 outside, integration of x square minus 2 square. If you look at the second term, this 4 I'm writing it as 2 square.
So 1 upon 2 into log x minus a upon log x plus a.
1 upon 2a into log x minus a upon x plus a. Okay. तो दो बार log नहीं आएगा. It will be only one time log.
Yes, same thing.
But then your the formula was almost right. Good. So this is x 5 and 3, 4, 1 upon 2a. Always write down the formula first. 1 upon 2a log x minus a upon x plus a. So this will be 2. The value of the first box bracket will be 2 because it will be 5 minus 3. Box minus box, that is 2. Plus 4 upon 2 will give you 2. The value of a is also 2. Again, there is a cancellation over here. Log modulus x minus 2 upon x plus 2. put a box bracket 5 and 3. Okay. So 2 plus, once again there will be box bracket minus box bracket. This 2 will be the separate term. So 2 plus box bracket minus box bracket. Okay. Log 5 minus 2 upon 5 plus 2. Upon log 3 minus 2 upon 3 plus 2. So 2 plus log 3 upon 7 minus log 1 upon 5. Okay. So 2 plus log 3 by 7 divided by 1 by 5. So 2 plus log 3 by 7 into 5 by 1. So that will give you 15 by 7. Log 15 by 7. Okay. Fine. So have you understood the solution for this problem? Yes or no?
Yes, sir.
Fine. Exercise 16b, question number 1, sub question 1. Integration of 3x upon 9x square minus 1 dx. Upper limit to lower limit 1. I'll first and foremost try to find out the derivative of 9x square minus 1. Guys, what is the derivative of 9x square minus 1?
18x.
Correct. The derivative is 18x. So can we make the numerator as 18x? Yes.
Multiply divided by 6.
Correct. Perfect. Multiply and divide by 6. So whenever getting the derivative is easy by some simple calculations, you can just make it as the derivative. Okay. So this is 1 upon 6 log mod, sorry, 18x upon 9x square minus 1 dx. So this is 2 and this is 1. F of x, sorry, f dash x, and down it is f of x. So we'll use the property of f dash x upon f of x. So the property of f dash x upon f of x is log modulus f of x plus c. Okay. So 1 by 6 log modulus f of x plus c. But then plus c won't come because we are in definite integration. Upper limit is 2, lower limit is 1. 2 and 1. So 1 by 6 log modulus f of x. F of x is 9x square minus 1, the modulus. So 1 by 6 box bracket minus box bracket, but then this time I'll also put a curly bracket because there is 1 by 6 outside. So in the first box bracket, I'll just put x as 2 log 9 into 2 square minus 1 within the modulus. Okay. Minus log 9 into 1 square minus 1. So the value of this is 35 if I'm not wrong, and the second log value is 8. So this can be written as 1 by 6 log 35 upon 8, because log a minus log b is equal to log a upon b, or a divided by b. Have you understood the problem? I've written the final answer on top. So let's go to the second sub question. Okay, integration of x raised to 5 1 upon x raised to 6 dx. Right? Now, if you take a look at the denominator, its derivative is x raised to 5, 6x raised to 5. So what we can do is, like the previous problem, we can just multiply and divide by 6 and then apply f dash x upon f of x property. Okay. So I'm not solving this in greater detail, but then a minute adjustment was required, multiply and divide by 6, so that we can apply the property. Third sub question, integration of x upon 1 plus x raised to 4 dx. Okay, so basically the derivative of the denominator this time is 4x cube. Now we don't have x cube term.
X square has 3.
Correct. So this time we cannot apply that property which we were discussing earlier. What we can do is, we can write this as x, and this is x square the whole square dx. X square the whole square dx. Okay. Now what we'll do is, we'll put x square is equal to t. Equation number 1. X square is equal to t.
Tan
Fine.
inverse t, sir.
Yeah, but then some steps we need to show in between. Na? So this was equation number 1. Right? So put x square equal to t. Method of substitution. D by dx of x square is equal to d by dx of t. 2x is equal to dt by dx. Now look at equation number 1. After this, look at equation number 1 and tell me which terms should we group it together. Tell me, guys.
dx is equal to dt by 2.
X dx, correct. X dx will be grouped together. So x dx will be dt by 2. Okay. Now some more thing happens over here. Some more thing happens. The upper limit and lower limit changes. In method of substitution, when we are applying method of substitution in definite integrals, the upper limit and lower limit will change. How it will change, I'll just teach you. When x is equal to 0, which is the lower limit, okay, we'll consider this t is equal to x square, which is equal to 0 square, which is 0. When x is equal to 1, that is the upper limit, t is equal to x square, 1 square, which is 1. So 0 will change to 0, 1 will change to 1. So in this particular problem, ideally there is no change happening, but then this situation might not be there for all the problems. So this particular step which I have written on the right hand side is a mandatory step. So luckily here there is no change, but then in rest of the problems or many of the problems, the changes will occur. So from 1, I will be 0 changes to 0, 1 changes to 1, x dx will be dt by 2. Okay, and 1 upon x square the whole square will be 1 upon 1 plus t square. Okay. Now this 2 will go outside the integration sign as 1 upon 2. This 2 will go outside the integration sign as 1 upon 2. And what is the integration of 1 upon 1 plus t square? It's tan inverse t. So this is half tan inverse t. upper limit and lower limit. So half, put a curly bracket, box minus box, because half is for both. In place of t, put upper limit, that is 1. In place of t, put the lower limit, that is 0. Tan inverse 1 is 45 degrees. So 45 degrees is nothing but pi by 4. And tan inverse 0 is 0. So the answer is pi by 8. Okay. See, I have not kept the answer in degrees. I have converted it into radians. So the answer is pi by 8 over here. Okay. So that is how it is. Method of substitution. Fine. Question number 1, sub question 4. Question number 1, sub question 4, integration 0 to 1 e raised to 2x 1 plus e raised to 4x dx. Okay, let this be
E raised
equation
to
number 1.
2x plus t. No?
So this will be e raised to 2x 1 plus e raised to 2x the whole square. Let this be equation number 1. Okay. Now we can put e raised to 2x as t. We can put e raised to 2x as t. Okay. This is t. So put e raised to 2x as t. D by dx of e raised to 2x. D by dx of t. Derivative of e raised to 2x is 2 e raised to 2x. Because e raised to 2x is e raised to 2x into the chain rule. D by dx of 2x, which is 2. Now look at equation number 1. Look at equation number 1 and tell me which terms to group.
E2x and dx. So you get dt
E raised
upon
to
1 plus
2x
t
and
square.
dx. Correct.
Again half tan inverse t.
Correct. So e raised to 2x dx is equal to dt by 2. Fine. Change the limits. Upper limit and lower limit will change. When x is equal to 0, which is the lower limit, e raised to 2x, e raised to 2 into 0, e raised to 0, which is 1. See, this time it is changing. The change is quite visible over here. When x is 1, 1 is the upper limit. T is equal to e raised to 2x, e raised to 2 into 1, e square. It will be e square. Fine. Okay. So from 1, I is equal to 0 got replaced to 1 and 1 got replaced to e square. E raised to 2x dx became dt by 2. So this became dt by 2 and it is 1 upon 1 plus t square. 1 upon 1 plus t square dt by 2. Okay. Again, half will go outside. This right hand side step is very crucial. Half will go outside. Half integration of 1 upon 1 plus t square dt. 1 and e square. Okay. So half tan inverse t e square and 1. Half box bracket minus box bracket. Tan inverse e square tan inverse 1. Half tan inverse e square minus tan inverse 1 is 0. So this is tan inverse e square upon 2. Tan inverse e square upon 2. That is your answer. Okay. Guys, have you understood this?
Yes, sir.
Yes, sir.